Alright, so welcome back to our last video on rhombis and squares. Notice sometimes I put rhombuses and sometimes I put squares. Every textbook is a little different. Some use rhombi, some use rhombuses. I don't think either one is wrong. Again, it just depends on the current textbook that you have. Okay, so find the area of the given rhombuses or rhombis and squares. Okay, so because the rhombus and the square are parallelograms, we can use the parallelogram formula, which remember is just the base times the height that have to come together at a 90-degree angle. Okay, so when I'm looking at this, my base and my height for my first rhombus, my area is going to equal 4 inches, or 5 inches for my base, and then my height would be 4 inches. So my area equals 5 times 4 is 20, and since it's area, I know I'm going to have square inches, but I can't put the square on the 20. Some of you did that on your on 2 assessments ago and you got your answers wrong for finding area. You have to make sure that that square goes on the units. This is 20 inches squared. Okay? On the square, they're usually not going to give you 2 numbers. They're not going to give you both a base and a height, because since my corner comes together at a 90-degree angle anyways, right, I know, and all my sides are the same, I know both of these are going to be 16 centimeters. So my area, I'm going to come over here, is going to equal the base times the height. My base is 16 centimeters, and my height is also 16 centimeters. So when I multiply that together, 16 times 16, I want to say 196, but I'm going to check it just to make sure. Nope, 256. 16 times 16, I think I was doing 15. 256 centimeters squared. Again, you have to put that square on the centimeters. You cannot put it on the area, or on the number. Okay, and then the last one, whoo, that's itty bitty there. Let's see if we can zoom in on that last one. See those numbers a little bit better. There we go. A little bit better. Okay, so on this one, it's kind of hard to tell, but if I just turn my paper a little bit sideways, you can always rotate your paper all the way upside down if you need to. If I turn my paper like this, then it's pretty easy to see a base and a height. My base is going to be the same as all the sides because it's a rhombus, so all the sides are the same. So my base is 7, and my height is 3. So I'm going to use 7 and 3 for my base and my height, and my units are millimeters. So my area here is going to equal, my base is 7 millimeters, and my height is 3 millimeters. So sometimes you do have to turn your picture, like turn your head, turn your picture if you're making a sketch. So the area here, 7 times 3 is 21 square millimeters. Again, that square cannot go on the 21. It has to go on just the millimeters. Okay? Alright, so the last thing we're going to look at is sometimes they don't give you a base and a height. And there is another formula that we can use for a rhombus, which means you can also use it for a square if you need to, okay? But we usually use it for a rhombus. Sometimes you're just given the information about your diagonals, and there is a formula that works for that. It is 1/2 diagonal 1 times diagonal 2. So D1 and D2 just stand for diagonal. Diagonal. Okay, so it's just my 2 separate diagonals. So when I look at my first figure, okay, actually, you know what? I'm going to skip this one and come back to it because it's a little bit interesting. And I'm going to go to this one first, okay, because this is I have most information on this one. So I'm going to do the middle one first. My area is going to equal 1/2 the 2 diagonals. So what are my 2 diagonals? One diagonal is 10 meters. And the other diagonal is 18 meters. Okay, so when you do this in your calculator, you can do half of 10 is 5, and 5 times 18, that's fine. Or you can do 10 times 18 is 180 divided by 2 or multiplied by half, which is 90. That's probably what I would do, just because in my brain I already know 180 and then half of 180 is 90. But you can also do, again, 5, half of 10 is 5, and 5 times 18 is also 90. Millimeters or meters times meters is meters squared. And again, that square can only go on the units, it cannot go on the number. Okay? Alright, I'm still skipping this one. I'm going to come to this one next. Okay? Since I have a rhombus, well really, since I have a rhombus, it's a parallelogram. And since it's a parallelogram, I know those diagonals are bisected. So when I look at this one and I do area equals 1/2 diagonal 1 times diagonal 2, it doesn't matter which one you call diagonal 1 and which one you call diagonal 2, because you're just multiplying them together, right? If I came over here and I did 18 times 10, if I switched them, I would still get the same answer, right? Because 18 times 10 is still 180, multiplied by half is still 90. Or half of 18 would be 9, and 9 times 10 is 90. So the order you put your diagonals, it doesn't matter. I know that if this side is 2, this side is also 2, because they're the same. So that whole diagonal is from here to here, I know is 2 and 2, it's 4 units. Okay, my second diagonal, if this piece here is 6, that means the piece underneath it is also 6, because parallelograms have bisected diagonals. So this piece here is 6. Or sorry, not 6, 12. And again, I could have flipped these. I could have put a 12 here and put the 4 here. Doesn't matter. Okay? So then I end up with area equals 1/2 of 4 times 12. So I can do half of 4 is 2. And 2 times 12 is 24. Or I could do 4 times 12 is 48. And half of 48 is 12. I could even do half of 12 is 6. And 6 times 4 is 24. As long as you don't try to distribute that half, you can't take half of both of them. You only take half once. Okay? Only divide by 2 once. Now, since it's area, you're tempted to put squared, and you're tempted to probably put it right there on the 4. But remember, we can't square the number. We have to square the units. You can't square the number. You have to square the units for marking down that it's area. Alright, let's get to that last one, because we're missing part of the diagonal, and so I wanted to make sure we had time to discuss that. So when I look at this last one, and I need to know what this diagonal piece is here, I'm going to start with my area equals 1/2 diagonal 1 times diagonal 2. And because I just want to get it out of the way, I'm going to talk about what diagonal 1 is, because that's pretty simple, right? Diagonal 1, I'm going to call that one diagonal 1. Doesn't matter which one's 1 and 2. So if it's 6 and then another 6, that diagonal from here to here is 12. Then I need to know what the other diagonal is. Now, since it's a rhombus, and only because it's a rhombus, I know that my diagonals intersect at a 90-degree angle. So guess what I make right here? I make a little right triangle where I know my hypotenuse is 10, I know one of my legs is 6, and I don't know, I need to find this other leg. When I'm trying to find a leg in the Pythagorean theorem, I subtract. My numbers are 6 and 10. Always put the bigger one in first. So that's going to be 10 squared is 100. 6 squared is 36. 100 minus 36. 100 minus 36 is 64. And the square root of 64 is 8, right? 8 times 8 is 64? Yes. Okay. So that doesn't mean I put an 8 here. That's not the diagonal, right? That's just half the diagonal, which means my other half is also 8. So this whole diagonal then is 8 and 8, 16. Okay. So from there, I really do have 3 different methods that I could solve this, because I can do half of 12 is 6, and 6 times 16. 6 times 16 is 96. Or I could do half of 16 is 8, and 8 times 12 is 96. Or I could do 12 times 16, which is 192, and then half of 192 is 96. But each time you just divide one thing in half. You never divide more than once. And then remember, since it's area, I should be using squared, but we don't put it on the number, we put it on the units. Squared. Okay, so there is area. If you have your base and your height, treat it like a parallelogram. If you have your diagonals, then you use your diagonal formulas for the rhombus. Again, this only works in rhombis and squares. Okay, it's not going to work in every parallelogram. It's not going to work in every rectangle. It's only going to work in your rhombus and your squares. All right, thank you so much for watching. If you have any questions about area or rhombus or squares or rectangles or any quadrilaterals up to this point, please make sure you attend your sync time and stay for tutoring. All right, thank you so much for watching.